There we go. Okay. Pop out chat. Cool. Okay. Why is it so large? Okay. Oh, are we live? Sorry. Technical difficulties. Okay, okay, I'm here. Ah, good times. Okay, what am I doing? Alright, so thank you whoever is watching on YouTube, LOL, as I like figuring out my life. I'm also gonna go live on Instagram. Yeah. Okay, so we're gonna do that. Boop. Okay. Ooh, hello. Okay, so hi friends. I am live on two places, Instagram Live, that's that camera, hello, and YouTube Live, which is that camera, hello. So Instagram is probably my preferred, well, I don't know, I like both of them, but Instagram Live has a cutoff at an hour. I'm gonna try and finish this in an hour. We'll see what happens, but usually I end up talking and chatting with people, so it takes me longer to build, but that's okay, it's more fun. What am I doing? Okay, so I have a workshop coming up on Sunday, which I'm super excited about, because it's one of those rare magical workshops that is super fun for both kids and, well, I should say children of all ages, which includes adults. So if you are in the area, come check it out. It's super fun. But I am building an obstacle for that workshop. It's called Robot Mini Golf, and you build little robots to tackle obstacles. And this is one of them. Hello. But it's made out of cardboard. It's pretty dang cute, if I do say so myself. I built it in a couple of hours really quickly when I realized that the other previous robot head I had wouldn't work. Ooh, hello, friends. Is it just me? Oh, you don't hear my voice? Oh, no. Can you hear me now? That one commercial. Fun. Cool. Let me know if you have trouble hearing me, and I will talk louder, because I can be very loud if I need to be. But yeah, ping me with comments. I will try and keep an eye on it as I go. Because the reason why this is fun is because we can talk to each other and you can ask questions / share your ideas. So what am I building? I am building an upgrade to this obstacle, which on the inside, you can see it's already broken. Haha, fun. But basically, it's a drawbridge. So I have a servo in here, which I had wired up to a microbit. The reason why I used a microbit, on the original robot head, I ended up using an Arduino Uno. But I opted for a microbit, honestly, because it's a little bit smaller and it has push buttons on it. So I wanted to add features to make the obstacle a little bit harder. And so I decided to use a microbit because it's a little bit more work on my end to add buttons to the Arduino. Hopefully you can hear me. It's probably because I'm a little bit far away and I don't have my microphone in. I guess I could plug my microphone into my phone. But this is mostly a build, so yes. Right now I'm just talking about what I'm going to be doing. But the way that this works, there's a servo in here, which I've disconnected already, but it pulls down on this chain, like so, and then it raises the drawbridge on the other side. So, bloop, bloop, bloop. Yes, just like that. Okay, so what I'm going to do is I'm going to steal the chain from this. I'm going to set that aside for now. And I'm going to show you the upgrade that we have. Oh ho ho! Here we go. Oh yeah. Okay. Oh my god, it's so funny. I love it. So that's gonna be the new leveled up version of this cute little cardboard drawbridge. I also have other obstacles. This is actually the hardest obstacle. One of the other obstacles that I finished, just because I want to show you, is this. Oh, look, it's a ramp. Ah! You have to go down the ramp, not up. It would be really hard to make your robot go up the ramp. But it's like a ski slope. Ah, cute. Oh no, I need to fit in both cameras. So, yeah, so the other obstacles are, there's one more. I'm not done with it, so I'm not going to show you. Shh. But this one is the only one with electronics on it. And so I figured it might be fun for y'all to see me how I build it. Like the concept of the electric window or door. Yeah, pretty much. Or if you like to think about it in terms of castles, it's like adding electronics to your castle. Why not? Okay. Yes. So design choices. Anytime we build a project, I think one of the most interesting things in electronics is considering design choices, right? Because there are so many microcontrollers out there. How do you pick budget, time, and energy? And because I'm a lazy engineer, I always like to go with the simplest option. So I could wire up and connect an Arduino, which is a little bit more powerful than the microbit, but microbit has push buttons, like I mentioned before, so that allows me to add a little bit more features into my build. And I'm also going to upgrade the servo motor, hello friends, so that it is a bit more powerful. So this is a high torque micro servo. And the reason why it's high torque is because the gears inside are made out of metal instead of plastic. So because the microbit's not quite powerful enough to fully control a servo, or I should say fully power a servo, it can definitely control a servo, but I am going to be using extra AA batteries so that my servo motor can fully pull up the robot head. Oh, yay, hello. Cool. Okay, so here we go. The first thing I need to do is harvest the chain from this thing. And I will do my best to kind of keep an eye on the camera angles as I'm going. Okay, there we go. Oh, comment. It's not project on YouTube. They use Arduino and a servo motor to build an electric garage. Oh, that's cool. It's pretty amazing what you can use microcontrollers for. So, oh, that's funny. Sometimes my cleverness surprises me. So, I actually, before I unhook this, I want to do a close-up of this. So I used a necklace, and I ended up, I can break this, it's just cardboard. I ended up hooking the clasp. Oh, that's that's fine. That still works. So I hooked the clasp through the servo. It's funny. I entertain myself endlessly. So cool. I'm gonna just steal that for this next one. Good job, past Jen. Future Jen is impressed. Okay, so now, let's see. Oh, there we go. Okay, so it moves this way. So if I want it to pull down, I'm going to hook the clasp into one of the holes on the microservo. Boop. And hopefully it still fits. Oh no, it might not fit on this one. Foo! Oh, shoot. Dang. I guess I could, like, this one is way thinner. I wonder if this would work, actually. My guess is that this is thicker because it's a stronger microservo. Dang. Clever past gen might not help out future gen after all. Still impressed, though. Yeah, I don't think that's gonna fit. Too bad. We could try just replacing this and see how it goes. Boop. Oh, that's not gonna work. Okay. Hello. So yeah, let me know if you have any questions. I'm working with a servo motor and the microbit because it's easy. But there are lots of ways to use microcontrollers to open things. And in fact, I have a project that I'm about to go public with where I do just that with a full house door. And I actually used the microbit, which was an interesting design project because it was like, okay, can I use this tiny little board to do something pretty serious? Heck yes, we can. Okay, so now I have to decide how I want to hook the necklace into the servo motor. I guess I could. I guess I could just tie it on, but that's not very fun. I want to make it a secure connection. So what I could do is just flip this around and like put a pin in this or something, or some sort of metal, and then adhere it that way. I wish I had a tiny screw, but I don't have a tiny screw. So I actually could use a paperclip. That'll probably work. Let me see. I'm gonna get another paper clip. Do I have one in my portable maker bag? Out of curiosity, do y'all ever have to travel with materials? And if so, what do you bring with you? This is my portable maker bag, and it has pretty much everything in it. I say pretty much because it can't have everything, but it has all of the good stuff. Although I don't know if I have paper clips in here. No! How do I not have paper clips? Oh, but I have a tiny screw! Oh, that might work. Okay, tiny screw. Is this gonna fit? Tiny screw! Might fit in here. That's not quite what I wanted, though. Boo! Nope, not tiny enough. I need a very tiny... Oh, I didn't mean to drop that in there. Oopsies! Oh well, it's fine. Paperclip still probably the best bet. Alright. I was working with a student yesterday and we were trying a bunch of different things to the point where the workstation just got totally chaotic. And so a couple of times we had to stop what we were doing so we could clear off the desk. It's a welcome to my life. Okay. Oopsies. I didn't put everything away. Okay. There we go. Boop. Okay. Oh, tiny screw. That's fine. Paper clip. Wah! Whoa! Okay. Yay, paper clip. Boop. Okay, so I hope that this fits. Oh, that's really funny. Someone commented that they used to fly with a lot of stuff until TSA concluded that they're probably a terrorist. I have had so many frustrating encounters with TSA. So many. Like, okay, perfect example, wire cutters. They would not let me take these on board. And I was like, they can't even cut anything. Well, that's kind of a lie. But they're not like wire cutters. They're not very sharp. They just pull plastic off of wire. And they were like, no, you cannot bring these. They are a weapon. I was like, but I need them for a workshop. I was really frustrated. And I loved them. So I mailed them back to myself, and it was probably like $45. Super annoyed. So I know how that goes. You also have to be really careful, like if you're traveling with a hot glue gun, it's not a hot glue gun, it's a hot melt tool. You have to be very careful. Oh, TSA. So frustrating. LOL. So someone asked, will the microbit control the servo motor correctly? Hahaha, good question. So the microbit outputs 3 volts. These servos typically are like 5-ish volts. And it really depends. So I have seen some instances where the microbit has been able to control the servo motor. It's weird though because it might be the version number of the microbit, but sometimes it really feels like how the microbit is feeling that day, because sometimes it works and sometimes it doesn't. And if the simulation on MakeCode is showing that the servo motor should be moving and it's not moving, then it is probably the fact that the microbit is not giving the motor enough power. So what I would recommend when you're trying to use a microbit and a servo together, I would definitely recommend using an external power source. And since I want this to be portable, this one I actually plugged into the wall, but since I travel around and do workshops in all different types of locations, it's really hard to predict like where an outlet will be. And so learning from previous builds, I want to make something that runs on batteries. So the microbit is going to run on a separate battery, and then I have these 4 AA's in a battery pack to power the servo. So I hope that answers your question. The short answer is yes. The long answer is sort of. Does it use... Oh, good question. So the microbit kind of blurs the lines of a microcontroller because it actually has a microprocessor on board. And theoretically, that kind of makes it a computer. Because computers have microcontrollers and microprocessors working together. It has more of like a brain, you might say. But most microcontrollers, like the Arduino boards, are pure microcontrollers. And when I say microcontroller, I'm really referring to the chip. But an Arduino board does not have a processor on board. So what makes the microbit different is that you can program it in multiple different coding languages. Since I am a lazy engineer, I do actually like the MakeCode interface because it lets me build things super quick. But occasionally there are projects that would take longer in in MakeCode, which is a block-based interface. So I have also used MicroPython with the microbit. That's really useful if you want to do more complex projects. And then you actually can also program this in Arduino, and the Arduino language is called Wiring. It's like a combination of C++ and an artist-friendly language called Processing. I believe you can program it in C++. Yeah. AKA, you can, as long as you download the right firmware, which is software that kind of configures the hardware on the board, you can program it in pretty much whatever language you want. Good question. What would you prefer between the microcontrollers? Ooh, that's a really good question. So there are so many microcontrollers out there, which is awesome. It's really great problem of choice to have. But that said, it can be really hard figuring out which one you want to start with. So, I wrote a tutorial on how to do this, and then I upped the tutorial and I wrote a book on how to do this because there's a lot of information to cover. If you are interested, I would be willing to send you a PDF copy of that, or if you go to my website and you type in, that's funny. If you type in microcontrollers, it's called A Beginner's Guide to Microcontrollers, and I cover some of the most popular boards. I'm not going to dive into all of them because there's just too many to possibly know and or cover in like a reasonable length of time. But for example, I cover the microbit. Hold on, I have a thing here that is sitting over here. I cover the Circuit Playground Express, which is honestly, I like this a lot. This is a brilliant board. It's made by Adafruit. Lady Ada Lamore Freed, she's brilliant and is really good at designing boards that are not only beginner friendly, but you can do some really powerful things with this. And I would say the only caveat with this one is that it's a little bit harder to program than this. Not by much, there's just an extra step. But this also can be programmed with block-based languages on MakeCode, and same thing, it has a microprocessor on board, so you can program it in like MicroPython or C++. Yeah, I've done MicroPython before. I don't think I've done C++, but it's pretty much the same protocol. But anyway, so you hit a limit with the microbit at a certain point in terms of power and what you can do with it. But if you have a Circuit Playground Express, there's actually a lot that you can do with it. I would highly recommend it. Plus, it has a little speaker on board. It's so cute. It makes little jingles. Tee-hee. Yeah, so those are probably the two beginner boards, and then you can't go wrong with Arduino. Arduino's just been around for so long. There's a ton of resources out there, and yeah, very fun. Good question. Oh, it's funny. Yes, so yeah, check out Beginner's Guide to Microcontrollers. I also cover the Raspberry Pi, even though it's not a microcontroller. It's a computer, but it's really, really good for beginners. Cool. Keep the questions coming, and I'll try and keep up with them. Um, Yeah, MicroPython is amazing. I love it. And I keep saying MicroPython, but CircuitPython is kind of in the same boat. It is applied a little bit differently and the libraries are different, but I am really impressed with it. It's also really useful because Python is one of those languages that's great for machine learning and for more advanced data analysis stuff. It just makes the math a lot easier. I've done some projects. I've done the same project in Arduino and in MicroPython, and it's really interesting to see how much shorter the Python program is. Like, I'm talking like 3 times fewer lines. It's great. But then on the other hand, there's pros and cons to that too, because then if there are certain things that are fairly complicated to do in MicroPython, I'm trying not to stab myself as I try to wrap this paper clip through. Cool. So, that's okay that your phone turned off. If there's anything that you missed, you can always go back and rewatch. Haha! Okay. So, what am I doing now? Okay, so now I have this hooked up. I want to make sure that my battery pack is going to work with this. So I'm going to strip off a little of the wire so I can push it into the servo. And I believe, oh, afraid, of course it did. I believe that, I might need a little more because I think I pulled off some of the wire. My micro, my microbit, I wanted to say MicroPython, but my microbit should be programmed already. Oh my gosh, this might not work. So if I can just wire this up and plug the microbit in, I can test it really quick before okay, I bail on that. I can test it really quick before I build it, which is probably good to do. So I'm going to pull out some of my alligator 2-pin-ended clips, which, again, shout out to Adafruit, whatever. It's fine. Everyone knows what I'm talking about. The pin-ended alligator clips are super handy. Boop, 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 boop. Yay. Okay, so clip that here, and then positive to negative, positive to positive, negative to negative, but then I also have to connect the ground of the batteries to the ground of the microbit, otherwise they get confused because they don't know who's talking to who. Okay, and then that, and then the signal wire, bloop. Okay, so wires are all good. This has a switch, which is on. I unplug this, and I'm stealing electricity from my computer. Haha, okay. Alright, so you're supposed to turn on. Oh, okay, there we go. Ah, there we go. Cool, alright. Oops, camera. Sorry, my bad. Camera 1, camera 2. Okay, so it's moving, which is what I wanted it to do. So now I'm going to check. I think I have different modes on this. What did I... Oh, there we go, yeah. Okay, my instructions are starts in easy mode, which the signal was a ghost, and now I put it into hard mode. Okay. And then if I press both, oh, okay, I can't do that. Okay. Both of these should push it into, whoops, sorry, hardest mode. That doesn't seem like a hard mode. Oh, there we go. I made an angry face for the hardest mode. That's funny. Okay, cute. Good times. Okay, so it works. Yay! I'm gonna unplug that, and now I get to figure out how to connect it to the giant robot head, which is off camera. I also get to figure out how I'm gonna show you what I'm working on. Oh, that's a really good question. Keep the questions coming. I like them. They're really good questions. So the question was, do you think Python will be the language of the microcontrollers in the future? That is a really good question. And a hard one. And of course, it's my opinion. But I would say probably not, just because it's a higher level language. And I think that there are uses for different types of programming languages, right? Like when you're trying to do low level stuff, when you're trying to deal with like binary operations and serial communication and things like that, it is actually really useful to have C++ because you can do things without kind of overwriting stuff, if that makes sense. So there are definitely places where you'd want a lower level language, and there are just certain things that you can't, that are, I shouldn't say you can't, but that are really, really challenging to do in Python that in C++ you can handle like that, no problem. There are also like, it's kind of like Python is a great tool for what I mentioned, complex applications that involve pretty intense mathematics. So data science, some serious data analysis, machine learning, neural networks, those sorts of things. Python handles those really, really well. So I do definitely see that MicroPython and CircuitPython getting more popular as we port machine learning stuff onto microcontrollers, but I don't think that I see C++ or even really. Personally, I don't know assembly language, which is the language just below C++ and just above binary. I'm fairly comfortable with binary, but there's one of the things that I think is really important is for folks to understand how these things work at a very fundamental level. And so even though I don't know assembly language, I at least know what it is and why someone might need to learn assembly language. And what's frustrating to me sometimes is in tech education, there's a big push for coding, but it's almost always these higher level languages. And that's great, but we also need to recognize that there are uses for other languages and applications for those other languages. And so, for example, at a certain point, someone has to write firmware to be able to program a microcontroller chip to be able to take in Python. And we need people to be able to do that. So it's one of those questions where it's like it really depends on what you want to do with a microcontroller and what you want to do with your projects. So if you like doing data analysis and machine learning stuff and all of that good stuff, then yeah, learn Python because it's definitely becoming more ingrained within those communities. But if you like getting into the nitty-gritty details and doing low-level programming and understanding how things work on a very fundamental level, maybe start digging into assembly or more C++ and things like that. Yeah, I hope that answers your question. That is a really good question. It's a hard one. Cool. Oh, Unexpected Maker. Yes, I know them. I follow them. They do really cool stuff. A little ESP called the Tiny Pico. Yeah, so cute. Tiny board. Okay. So, this is where I realize I might not have enough tools with me to build this whole thing, but that's fine. We'll just get started. Okay, so now, okay, what I will do probably first is, oh, I am totally gonna have to drill this at some point. Okay, that's fine. I can do that. But for now, we're gonna use, what are we gonna use? Hot glue probably. Hot glue fixes everything! Yeah! No, it's fine. Okay, so what I am gonna do, what am I gonna do? So, what the servo is going to do is it is going to pull open the mouth, or pull close the mouth, and then gravity is gonna pull down. So, okay. So I want to connect this here, and for testing purposes, I'm just gonna glue this for now, and then I'll drill in some shenanigans. But I need to test this first, and because I'm a lazy engineer, I'm just gonna glue it. Okay, this is like the most awkward angle. Okay, so we're gonna fold this out. Okay, and then go like that. There we go. Whoa, it's falling over. Stay upright, please. Okay, okay, okay. It's a little large, so we're gonna move this back and angle this. Okay, okay, that's better. And for y'all, we'll see what we can do. Okay, so gluing. Boop. Do you like the colors I picked for the robot head? I'm pretty stoked on them. I think it's adorable. Okay. Okay, so we're just gonna hot glue this necklace chain. Efficiency, yes, exactly. I legit joke that I'm a lazy engineer, but the thing is, like, there's a reason for that, because I have a lot of things that I do, and I don't have as much time to spend on all of them as I would like. Slash, oftentimes my goal is just proof of concept. And so, in that case, it is efficient to be lazy. And legit, I have gotten clients because I admit that I'm lazy, so I always look for the simplest solution. I would highly recommend it. Especially because when you are trying to prove a concept, it really doesn't benefit anybody for you to put in way too much time. It's just frustrating. Because then you're like, oh, I put in so much time, and then it doesn't work. Marley, you're barking at a chair that I knocked. Hey, quiet. Silly dog. I bumped a chair into the wall. Oopsies. Do you think the... Wait, hold on. Is there a difference for each microcontroller? Different language for each microcontroller? Oh, yes. So microcontrollers are going to have different languages. Like I said, some of them have microprocessors on board, which means they can compile the programming language on the board itself. And so that makes it versatile. So all you have to do is download different firmware, which configures the board and tells it what language you want to program it in. And then, for example, both the Microbit and the Circuit Playground Express can be programmed in pretty much any language you want, as long as it has the appropriate firmware. So you can do, the default language for these is JavaScript slash MakeCode. I don't know how you would classify MakeCode. It's block-based. But then it's easy, I should say, it's reasonably easy to set them up for MicroPython slash CircuitPython. And Adafruit is really doing a great job of supporting CircuitPython. What other boards have onboard compilers? Honestly, a lot of the new boards are a lot more powerful. Unfortunately, I haven't had a chance to play with all of them, but another popular board are the particle photon boards, and they have a series of kind of like connected boards. And so those ones are programmed in a language that's almost identical to wiring, which is, again, the Arduino language. And then Arduino is programmed in wiring, which is very similar to C++. So old school microcontrollers would have been, you would have had to program them in something like assembly, which is a very low level programming language, and it's not very human readable. Still better than binary, but there's definitely a steep learning curve. So if you want to learn a particular programming language, you can look for what boards support that language. Do you think the IEEE would push microcontrollers to focus on... Oh, interesting. That's a good question. I don't really think so because I know that they push the 802.11b standards, right? I think that IEEE was a big proponent of wireless communication standards. I think so far that, interestingly enough, I would argue that manufacturers are doing a pretty good job of supporting different languages on boards, and I might credit Adafruit for a lot of that work. And I'm sure there's other companies that deserve credit as well, but I'm blanking on them. But yeah, I think actually of all of the things, microcontrollers are really well standardized. Like almost all of them switched at the same time to be powered by micro USB cables. It's interesting because when I first started learning electronics back in 2012, 2013, everyone used the, what is it, the mini USB, and a few years ago they all almost all at once switched to micro USB. And so I haven't used my mini USB cables in a really long time, but I have a ton of micro USB now. So yeah, I think standards for microcontrollers are doing pretty well. That's a good question. Any more side questions? But are you streaming on a? Yes, I am. I am trying to stream on multiple platforms, mostly because it's hard to get them all to talk to each other. So it goes. But also because Instagram limits your live streaming to an hour, and I never finish builds in an hour, especially when I get to talk to cool people like y'all. So yeah, if you wanna if and when this one tunes out and you want to keep watching, you can hit up the YouTubes. Okay, so where am I at? So now, okay, so now I'm gonna have to figure out what I'm gonna do with this paperclip at some point, but this will work. It's fine. And then, which way is this gonna turn? Oh, uh-oh. Okay, it's gonna turn this way. So, I will probably do what I have done before and add in a couple of pulley systems. I might actually have some in my maker bag. Boop. Okay. Yeah, I'm not sure which which camera has a better angle. Actually, I would say the YouTube camera has a better angle. Because I can move that one. Question. Why there's no microcontroller? Oh, that's funny. Why is there no microcontroller that supports USB-C? That's a really good question. I don't know the answer to that. Ah! You got me there. Yeah, I honestly don't know. It probably has something to do with the way it sends data. Good question. I will have to Google that one. We can program. Oh, yeah. So, you can actually program some microcontrollers on your phone. The Photon boards are a good example of that. Or, sorry, the particle boards. Photon is a specific board made by the company Particle. They also make all of their boards have like particle physics names. So the Photon is one that I've used many times before, and then the Electron is another one that's really popular. These are great questions. So yeah, you can if you use the particle photon boards, it has a little app that's super cute that you download for your phone, and it's actually very similar to MakeCode in the sense that like it's kind of like you click things and you drag things around and then you can turn lights on, and it's fairly straightforward for beginners to use. You do hit a wall pretty quickly, so like if you're like, I want to turn on a light, woo, you push the buttons and you wire it up, and the app will show you how to wire it up. But then you're like, but now I want to read in a sensor, and it's like, oh, that's my dog. Hey, Marley, it's okay. He's like, no, it's not. There's someone at the door. Hey, come here. I should give my dog a bone the next time before I start this. Anyway, so using the particle photon boards, they have an online web interface that allows you to program the board, and it requires you to set up the board on the app first, because it actually programs it via Wi-Fi, but that also means that you can type in code on your phone and it'll be uploaded to the particle photon board, which is super cool. Or, well, the particle board in general. Actually, if you want to see one of them, I have one in my maker bag. Yay! I think I have one in my maker bag. I thought I did. Let's see. I keep a tiny little box of handy dandy boards. Oh, boom! There it is. Yeah. Boop. So that's the photon. And this thing in the middle is the chip, which also has Wi-Fi access. So yeah, I love these boards. They're super, super handy. And Particle makes a bunch of other Wi-Fi enabled boards. So yeah, check them out if you want to program your microcontroller on your phone. Actually, the reason why I connected with them a while ago is because on my ridiculously long list of to-dos, and eventually I'll get to it, is to create a workshop for the photon boards, specifically because you can program them on your phone. So computer access is often a major barrier, and it's understandable because laptops are really expensive, and as a small business owner, I don't yet have the funding to invest in thousands of dollars worth of laptops, but what I could do is have people bring their smartphone and then we learn how to code on the smartphone. And I really want to have a workshop in a park because that sounds really fun to me. Work on electronics outside in the sunshine? Yes. Anyway, I digress. I'm supposed to be building my robot head. But these are really good questions, so thank you very much for asking them. And I will try and keep up. So right now, where are we at? Okay. So we have a servo, and I found my little metal pulley thingy. So I will be using this. Well, it's kind of actually more of a bearing than a pulley, but that's fine. It'll do the job. And then if I manually pull up, it'll open and close the mouth. Ha ha ha. And I'm gonna see if I can try. Okay, so you're like, this is not electronics. You're just doing this by hand. I know, but I have to test these things first. Ooh, I should turn the battery power off. Okay. Don't waste battery. Okay. So, oh my gosh, it's 5:30. What happened? How did that happen? Okay. So, I would like to put this here, I think. Oh, I'm probably going to hot glue again. That's fine. But this time, I'm going to find a skewer. Boop, 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 boop. And then we will do this. Boop, 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 boop. Okay. And I will probably redo this. This is just for testing purposes. Because this is going to involve a little bit of woodworking, but that's fine. Because that'll be fun. And then I'm going to smush the glue so that it dries faster. And maybe is a little more secure. I don't know if that actually helps. But we'll pretend. Fun. Is it possible to program a microcontroller using Bluetooth? Yes. Well, so Bluetooth is really just Wi-Fi. Bluetooth is a low-range Wi-Fi signal. I can't remember the wavelengths of Bluetooth off the top of my head. I have too many things in my head, and I use Google for the other things. But yeah, so Bluetooth is just a radio signal like Wi-Fi or like cell phone waves. Bluetooth oftentimes is low energy, aka Bluetooth LE, Bluetooth low energy. So it's really like a short range radio wave. I want to say that is how the particle boards are programmed, but don't quote me on that. It does require Wi-Fi access, so it might be using your Wi-Fi signal, but there are probably boards that you can do Bluetooth. If you've ever heard of Sam Labs, they have some really interesting, wireless modules that use Bluetooth. They make some really cool stuff. It's kind of like doing component by component building, so they don't really have, well, I shouldn't say that. They probably do have a integrated circuit chip, but they have little blocks. One's a motor and one's a light and one's a sensor, and then you can program them via Bluetooth to do separate things. So yes, There are definitely things you can program via Bluetooth. That's not exactly my forte, so I would not quote me on that. But there is more than the things I mentioned. Good question. Okay, so bearing is attached. Okay, boop. Hello from Brazil. That's awesome. Woo. Okay, so now this is where I'm like, what happens when you move, motor? What are you gonna do? Is that gonna pull up the head enough? Okay, so I might need to add. Okay, this is the hard part, is where I'm trying to hold all the things. Oh no. Okay. Okay. So we're gonna do. Oopsies! It fell off of the pulley. No, get back on, please. Oh, that might be an awkward angle for it. Okay, we're gonna do. If it moves down like that, will it? Oh, it barely moves the thing. Okay, so we're gonna have to add a couple more pulleys to exacerbate, or amplify, I should say, what the servo motor is going to be doing. Okay, so bear with me, I'm literally figuring this out as I'm going. So, this is part of the process. What am I doing? I don't know, let's figure it out. Oh, shoot. Okay, so this is not going to work. I think I'm just going to glue this directly to the... I will go back and fix this. Okay, so bail on that. We're just going to... Sorry, bearing, I know this is not really what you're intended for, but that's fine. You make it work. Okay. So now, that will be a little bit more stuck on. Still an awkward angle, but that's fine. Okay. And now, if I kind of want... Okay, so it needs to go all the way down. But, okay, if it goes like that. I need it to move a little more. So, what we're going to do... Oh! Okay, that may not work. Oh, I'm going to need a screw. That's fine. Okay, I have an idea. More questions. If you used a microcontroller for a project using a Wi-Fi, does it mean that it could be... Oh, does that mean that someone else could hack your microcontroller? Yes, absolutely. Great question. So anytime you configure your project up for a Wi-Fi, you are sort of opening a door to potential vulnerability. That said, as long as you're... So if you're... Okay, I'll back up. Your router sets up like a private closed network, basically. It's kind of like a front door. So if you have a password, it's like locking your front door. If you don't have a password on your router, it's like leaving your door unlocked or really leaving your door open. It's like, or like your keys in the door, which I've done. Oopsies. So your router kind of like protects your home. So if your microcontroller is behind your router, you're fine because someone would have to crack your router to get to your microcontroller. Smartphones, on the other hand, I had a friend that did a project where she gathered data that was sent from Tinder and basically pulled all of that data, and apparently, and this was a few years ago, so this has probably hopefully been fixed, but the Tinder data was not encrypted, and so she was actually able to get an awkward amount of information from all of the packets of data that were sent from someone using the Tinder app that was then going to their smartphone carrier. And so she made an art piece to demonstrate this, and she kept all the data anonymous because she was a good person. But if there is someone that knows what they're doing and you're using your smartphone, or you are using your smartphone to connect with your microcontroller, there is some potential vulnerability, which depends on the particular app that you're using. Every app is different. Some are better than others. So in that sense, if you're doing something that is like private or potentially like let's say you are using a microcontroller to control the heating in your home. you might want to connect that to your local router and not your smartphone. Routers are way more secure than smartphones. All of that said, not a ton of people know how to do these types of things, slash it can be time intensive. And so if you're just like a random person on the block who wants to build like an internet connected sensor for your home, you're probably fine. If you're Bill Gates, you're probably not fine because everyone knows who he is. So it's one of those like I think it's really important, one, to build projects because you understand where the vulnerabilities lie, and also you understand how hard it is to crack into stuff. Um, but you know, it's good to protect yourself and to think about these things. If you use the Raspberry Pi, though, you should absolutely change your default password, because, like, that's a popular computer now, and everyone knows the login's Pi and then Raspberry. Oh, boom, you're done. So, yeah, change your passwords, and just do your due diligence. But if you're behind your router, you're fine. Good question. Yeah, I know, right? It's pretty wild. Slash, when I lived in Los Angeles, I had a hacker friend that was like kind of notorious for taking hardware and trying to find its vulnerabilities, and I know that he was able to create a key logger for a wireless keyboard because the wireless keyboard was sending information that was unencrypted, which is just like, really? Okay, that seems silly. But yeah, anytime. So the term tap in, like spying on someone, literally meant you would cut the connection cable and you would literally tap in another cable into that. Like you would splice in a wire. Like, let's say I wanted to steal the information that was sent through this cable. I would cut open the cable, I would find the data cable, and then I would go and I would connect my own sensor cable into this cable. And then I would wrap it up and make it look like it hadn't been tampered with, or I would just like hide it or whatever. And then you would listen into that physical cable. But now, because all of our data is wireless, you can kind of like tap into that radio signal. And that's why it's really important for our signals to be encrypted. Security. Don't want anyone to get our bank account information. Ah! Or just like, I think privacy is super, super important because there are certain things I don't mind sharing with the public, like all the stuff that I'm talking with you about. But there are sometimes I want to just like check out and tune out and turn off the world of electronics, and I should be able to do that. So, privacy and security are important. Thank you for asking. Okay, and now I'm like, how am I gonna connect this bearing to here? Let's see, how much time do I have? Okay, I have a little bit more time. Um, let's see if I have anything in my handy dandy. Oh! Oh, that's cool. Okay, so the problem with keeping all of my stuff in these containers is like I have toothpicks in here, and it's one of those like, ow! I poke myself. Ow! No, not again. Ah, reaching into it. Pokey container for a tiny thing at the bottom. Oh, boom! Woo! Okay, so let's see. I can also use this. This might be better, maybe. Okay, so just to show you what I did. Oops, that's upside down. Okay, so on this last one, how do I fit it into both cameras? Okay, there we go. Okay, so on this last one, I'll bend down so I can be in camera 2. Sorry for the folks on YouTube, my face is like all over the place. Okay, so in this one, I used paper clips to to kind of guide the pulley for the drawbridge. Boop, 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 boop. I also used a paper clip to attach it. But this is moving cardboard. This is very, very lightweight. This is a lot heavier, and so hence why I'm using the higher torque servo, and I will probably have to use something besides paper clips that are hot glued together. But hot glue comes off really easily, and so it's a good way to test things, because why would I measure? That's silly. Ugh, plan ahead. Ridiculous. But anyway, so let's see, okay. So, talking out loud, so that I can think how I did this last time. The pulley went up through here, and then up this way, and then the servo motor was here. So, maybe what I wanted to do is I take this And maybe I extend it this way so that a motion this way causes a little bit more pulling uppy motion. It's a technical term, pulling uppy motion. Okay, good times. Let's see, another question. Oh, that's cute. Yeah, I am always open to questions. Please bug me. Um, it's important to learn. So, and my live builds are like a totally random. So thank you for showing up and watching because my schedule is kind of all over the place and it's really hard for me to plan and keep these consistent. So I appreciate y'all for watching. Like, oh, random Friday afternoon. Yeah, let's do it. So I have about until 6 and then I like actually have to build this because I have people coming over. Oh my gosh. But actually have a maker night. It's gonna be fun. Hello, friend! Yay! Another question. Do you think the microprocessor would kill the trend of microcontrollers? Ooh, that's a good question. So, microprocessors work with microcontrollers. So, the difference between a computer and a microcontroller is that a microcontroller typically really does one main thing. It runs a program in a loop. It usually has a setup loop, where it configures certain parameters, and then it has like an infinite loop where it just keeps running that over and over and over again. That's why unplugging and plugging your router back in works, because it's a microcontroller. And so you basically are forcing it to go through that setup loop again. So if it does something wonky in the infinite loop, you're like, stop that, go through the setup loop again. But a computer has a microprocessor that does the heavy lifting, and heavy lifting of running the instructions, doing the calculations, and then it offloads certain tasks to microcontrollers. So a computer has microcontrollers in it. A microprocessor uses microcontrollers to do different things. And so that might be for example, your graphics cards are actually, I don't know if they're microprocessors or microcontrollers. So I'm going to backpedal from that one. But basically the general idea is that a computer is going to have a microprocessor running calculations and doing those things, and then it has microcontrollers oftentimes to do the hardware stuff. So like run the CD drive. Do computers have CD drives anymore? I don't know. But like interface with the keyboard. My guess is that the thing that's running your keyboard, that is taking in the keystrokes and is translating them to the microprocessor, that's probably a microcontroller. A mouse, like not a little cheese eating mouse, but a little click click mouse. Those are microcontrollers. And I'm kind of being a little hand wavy here because as microprocessors get cheaper and cheaper, it's easier to just throw a microprocessor in it. Woo! Fun! But there's definitely the need for both of them because they do different things. Yes, good question. So I hope that helps. Engineers are usually specifically random people. That's hilarious. Oftentimes, yes. Oh, squirrel, I want to do this thing. Yeah, welcome to engineering. It's very funny. Yeah, I am one of those engineers that, like, I have too many things that I'm interested in and too many things that I want to do. But that's fine. I define a microcontroller as a single chip computer with built-in peripherals, whereas a CPU needs external support components to build a complete computer. Yeah, totally. Yeah, so like a microprocessor isn't really, it's running calculations, but it's not like doing things. You could kind of think about it like your brain's kind of like a microprocessor where it's like doing a lot of things that are very complex. It's having a lot of complex thoughts. And then the microcontrollers would be like your hands. Like your brain's like, hey, do some things. And then your hands are like, okay, cool. Or like your mouth, like your brain's like, say some things. And it's like, okay. And so you say some things. So you like the things on your body are like the microcontrollers and your brain's like the microprocessor. And I'm putting that in quotes because it's not like a perfect analogy, but it's a decent way of thinking about it. great questions and excellent discussion. I love these things. I'm always really stoked on the questions people ask because it forces me to grapple with what I know and what I don't know, which I know a lot, but I also don't know even more. So good times. Yay. Ha. Oh yeah, so, for those of you that are asking questions or are interested in the discussion but are like, I'm not gonna remember this, yeah, I feel you. This will be stored live on YouTube, so boom, go check it out. I think Instagram Live keeps it up for like 24 hours, which is not nearly enough time, but it will be stored live on YouTube, so yeah, you can watch it forever and ever. You just have to figure out where in this random video that we had that discussion, and then you're good to go. I don't know if we can search videos yet, but, yes. Why, hello, friends! Okay, so, where are we at right now? So, right now, we are... I'm still stuck trying to figure out, because I'm like, do I want to do woodworking on my live video on my kitchen counter? Good times. I might actually be that person and be like, ooh, I need to not do it live, but we'll see. Oh no, the Instagram live video is ending. Foo. Okay, this is why I have both of them. Okay, so for those of you on Instagram, thank you for watching. Yay! Check out the full video on YouTube and let me know if you have any more questions. Bye! Turning off. How do I turn this off? How do I do these things? Okay. For someone that works in tech, I'm hilariously I'm like, how? I don't understand Snapchat. That one's a little easier. What is it? TikTok? I don't understand TikTok. I tried TikTok and it made me feel old. I'm not that old. It was just like, what is this? Oh my gosh, I need to drink some juice. Okay. Juice satiated. Cool. Okay, so I need to... My bearing is not going to be glued, so I guess I could put... I really don't want to poke holes in this until I'm confident of what I'm doing. Okay, but now that I have one camera, it's a little easier. So we're gonna do this so that I can scooch on in and really think about this. Okay, so if I want to... Woo! And maybe scooch that way. Scooch it a little that way. Okay. Okay. So which way is this gonna rotate? It's gonna rotate that way. Okay. So let's see. Okay. So what I could do... No. Okay. So I guess I could also ask the question, where do I want the servo to go? You know what I'm gonna do? I'm gonna get some tape. Okay. Okay. I got my painter's tape so it can, like, hold things for me, because I only have 2 hands so far. One of my projects on my to-do list is to build extra robotic arms, because that would be useful. Yay. Okay, so... Let's see. Thank you. I like my robot head. It's pretty funny. Okay, so I need to just... Well, okay, can I tape it this way? No, because that's gonna hit. So I need to tape it out like this. Okay, I really just need to figure out where. This is gonna be an awkward way to tape it. Okay. Unless maybe I do it. No, I can't do that. We are gonna do this somehow. I'm not quite sure. This is not gonna work. Okay. I bail on tape and I go back to hot glue because that's just a weird angle. Okay, that's fine. I'll just pull this off. Okay. I really just need to figure out how it's gonna, where I'm gonna put my pulleys. So if I hold this here, there we go. Okay, I should let that dry. Let's see. So then maybe I use this S thing like up here so that, okay, so I can only hold one of the two of these, so let's see which one I can get away with. I bet I can glue this down somewhere. Oh, that's a really good question. Am I building a Minecraft Steve head? I should call it that, but actually no, I don't know. This is random creation. Maybe subconsciously I was inspired by Minecraft. Silly. Good times. This was so this is an obstacle for one of my workshops where folks are gonna be building little kind of brush bots. They're super cute. They're little wiggly wobbly robots. And so you don't really program them. They're just a motor with a counterweight, so they shake. And so I thought to give folks a way to program them, aka think about how you can control the little brush bot with different design techniques. A good way to think about that is to give people obstacles. And so this is my oh no. This is my robot head. So I think it's kind of funny because it's like feed the robot the tiny robots. So silly. Yes, good times. Okay, so now that is dry, and so I'm gonna try and pull this up here. Okay, and maybe hold that. Or maybe I pull it down. Maybe that's what I do. And not knock this over. Okay. Oh my god. Okay. Here we go. Is this gonna work? Maybe. Oh, that barely pulled it up. That's lame. Okay, what else can I do? Well, I noticed that... Oh, I think maybe if I rotate this, that might work better. Okay, so it needs to be flat when it's... Okay. Whoa! Come on. That's not gonna work. Foo! Okay. The goal is that it pulls up. So, I only have a little chain. Oh, do microcontrollers use Java for programming? That's a good question. I don't think that there are any microcontrollers that use Java. I'm using the microbit because I want to be lazy. And so this one you can do in JavaScript, which is a different language, but you can also program it in block-based languages on makecode.org, and you can also program it in MicroPython. Yay! Good question. Do you think Minecraft is a good game to learn programming? Oh, that's interesting. Honestly, if you want to learn programming, find something that you care about. So if Minecraft is motivating for you, then yes, it's a great place to learn programming. What language? I think, is it Python that you use to add blocks and stuff now? I've done that before, but it's been a long time. It's been like 2 years since I've done that. So I can't quite remember. But yeah, if you like to build stuff in Minecraft and you want to learn programming, heck yeah, do it. For me personally, I really like hardware because I like building things in the real world. The way that I learned programming was when I was, hilariously enough, I managed to get two science degrees, or well, one science degree and an engineering degree without having to learn to program. And so when I wanted to learn how to build things, so I did an independent project. And that is how I had to learn to program because turns out to build things in the real world, you almost always have to program them. So I used one of the first Raspberry Pis to build a soil moisture sensor that controlled an irrigation system. And that's how I learned to program. And so if you want to learn a program, just find a project that you care about and build it. And why don't you use a stepper motor? Haha, good question. So stepper motors are just a little bit more of a pain to control with microcontrollers. And the other thing that worries me about a stepper motor is like it's a little bit more intense. So what's nice about a servo motor is that it's not gonna damage the robot, and it's like it's very safe. This workshop is geared towards, well, folks of all ages, and so because the electronics are exposed, which is on purpose, I want folks to see how I did this. Because the electronics are exposed, I wouldn't want there to be a risk of damage. So in this case, if something were to happen to the servo motor, it's kind of like, whatever. It's not a big deal, they're not very expensive, they're fairly straightforward to replace, and they're not gonna really do anything. So, no pinched fingers, nothing like that. That's a really good question, though. Yeah, good times. So, I think, unfortunately, I am out of time. This always happens when I do live builds. I like to talk. But, okay, I at least got to the point where I, like, sort of know what I'm doing. Okay, so we're just gonna hold this down here and maybe redo that a little bit. I might end up wrapping this around. We'll see. Okay. But yeah, I have to think about this a little bit more. But at least I did something. Haha! Okay. I got started, which makes my life way easier. Okay, so I'm gonna flip this around before I go so you can see the front because it's silly. Boop. And very large. Haha! Okay. And I'm gonna poke my head through. Oh my god, okay. So, thank you for watching. Let me know if you have any questions. You're welcome to comment on the video, and I will do my best to answer them. Slash, if you have any ideas, if you're like, why are you using a servo motor? That's stupid. I might, I might revisit this project. I do have a pretty powerful DC motor. I don't know if I have a stepper motor on me. I probably do somewhere. But I might. It depends. So, ooh, yes, I would love to do more live videos. Like I said, my schedule is all over the place. I'm currently running a company, although that might change soon. Shh, don't tell anyone. But if you have requests, please let me know. And if there are specific times that you would like me to do live builds, ping me. So, like, this was just a random, like, I have to finish this by the weekend, and so I figured, well, this might as well get started on Friday. So I don't have to do it tomorrow. Haha! But, yeah, if Friday evenings are good for you, let me know. If you prefer Monday nights, let me know. Usually Mondays are when I do math videos, but we can be flexible. So yeah, please let me know what works best for you as I talk to you through my robot head. Okay. Thank you so much for joining me, everybody. Thanks, Peter from Boulder, and for chipping in your engineering sense, literally and metaphorically. And hopefully I will see you all again soon. Yay! Okay, bye, friends! Woo! Steppers are current hungry. Ah, thank you. Yes, exactly. Yeah. They steal a lot of energy. That's a really good point. I knew there was another reason I wasn't using them. Yeah, I totally thought of that. Thank you, Peter. I really appreciate it. So yeah. Hopefully y'all were entertained and maybe learned something and or had a good time. I did. I definitely learned something. Alright. Goodbye, my lovely friends on YouTube. Bye, Peter. Also, take care and have a beautiful weekend. Woo! Party time! Excellent.